Welcome back to the channel. In this video, we'll look at cosine. Cosine, like sine, is another trigonometric function which relates the size of an angle to the sizes of two sides in a right-angled triangle. So let's start with a right-angled triangle, and here we know that hypotenuse is of length 9 centimeters, the hypotenuse being opposite the right angle. We also know that this angle is 36 degrees. And here we want to find the length x. Now x here is the adjacent side, adjacent next to the angle. So here we use cosine, and if we write down the definition of cosine, we get this. Cos 36 degrees is equal to the adjacent divided by the hypotenuse. And in this case, that will be x over 9. Now we need to find the value of x. So to do that, we will multiply both sides by 9, or we can say cross multiply. Doing that, we get x equals 9 multiplied by cos of 36 degrees. And we can look up cos of 36 degrees on a calculator, and then we will get this line. And multiplying those two figures together, we get x is equal to 7.281 centimeters. That's correct to four significant figures. Now let's look at a triangle in a different orientation. And here the hypotenuse will be of length 12 centimeters and the angle 40 degrees. And again, we want to find the length x, which is the adjacent side next to the angle, the 40-degree angle. So let's write down the definition of cosine, and it is cos of 40 degrees is equal to the adjacent over the hypotenuse. And here, that will be x over 12. So now to find the value of x, we multiply both sides by 12, or we can call it cross multiplying. If we do that, we get x is equal to 12 multiplied by cos of 40 degrees. And looking up cos of 40 on a calculator, we get this. And multiplying those figures together, we get x is equal to 9.193 centimeters, again correct to four significant figures. Now let's look at this triangle, another right-angled triangle, and here we know the adjacent length, it's 8 centimeters, and here the angle is 33 degrees. And this time we want to calculate x, where x is the hypotenuse. Again, we'll use cosine, so let's write down the definition. Cos 33 degrees is equal to the adjacent divided by the hypotenuse. Now in this case, that will be 8 divided by x. So how can we get the value of x here? Well, we need to multiply both sides by x, or again we can call it cross multiply. And if we do that, we get x multiplied by cos of 33 degrees is equal to 8. Now let's divide both sides by cos 33 degrees so we can get x. Doing that, we get x is equal to 8 over cos 33, and looking up cos of 33 degrees on a calculator, we get this, and doing that division again on the calculator, we end up with x is 9.539 centimeters, again correct to four significant figures. Let's consider another example where the triangle is in a different orientation. Here again, we know the adjacent length, it is 7.5 centimeters in this case. And the angle is 54 degrees. And we want to find the length x there, the hypotenuse. So let's write down the definition of cosine. Cos of 54 degrees is equal to the adjacent over the hypotenuse, which here will be 7.5 divided by x. And now to find the value of x, you remember that we need to multiply both sides by x or cross multiply. And when we do that, we get x multiplied by cos of 54 degrees is equal to 7.5. Now to find the value of x, we simply divide by cos 54 degrees, and we will have x is equal to 7.5 over cos 54. And looking up cos 54 degrees on a calculator, we get this. And doing that division on a calculator, we find that x is equal to 12.76 centimeters, correct to 4 significant figures. Now let's look at a slightly different example. Here we are given that the adjacent length is 8 centimeters. And we're also given the hypotenuse. It is 10.5 centimeters. And in this case, we want to find the angle, and we'll call the angle theta. So what should we do here? Well, we simply proceed in the same way. So write down the definition of cosine. Here, that will be cos of theta is equal to the adjacent over the hypotenuse, which is 8 over 10.5. We can now do that division on a calculator. If we do that, we get this 0.761. Now we need to find the value of theta, and we can write that as theta is cos to the minus 1 of 0.7619, etc. And to get the value of theta on a calculator, we must put the 0.7619 on the calculator screen and press the cos to the minus 1 key, or it could be arc cos on your calculator. When you do that, you should get 40.37 degrees. And again, that's correct to 4 significant figures. Let's look at another example with the triangle in this orientation. And again here, we know the adjacent length, it's 5 centimeters. And we also know the hypotenuse, here it is 9.5 centimeters. And we want to calculate the size of the angle theta there. So once again, we will write down the definition of cosine, it being cos theta is equal to adjacent over hypotenuse. And we know those lengths, they are 5 divided by 9.5. So now we can do that division with a calculator, and we get this 0.5263, etc. And again, let's write down theta is cos to the minus 1 of 0.5263. And if you remember, to get the value of theta now, we need to put the 0.5263 on the calculator screen and press the cos to the minus 1 key, or the arc cos key. When we do that, we find that theta is equal to 58.24 degrees, correcting to 4 significant figures. So that's it for this video. I hope you've enjoyed it and learned something. Now again, I'll mention that I have a website where you can get unlimited practice in solving problems of this kind. And there's also a tests site associated with it, where you can take a short test to see if you've learned and mastered what we've done here. 5 consecutive correct answers will complete the test and you'll receive a message, congratulations, etc. So thank you very much, and I look forward to seeing you in the next video.